Vitrified paving brick is a surfacing material that is essentially pre-manufactured. Its qualities and thickness can be determined before it goes onto the job. The durable units of a brick surface form an armor that protects the base course from the direct action of traffic as well as from extremes of temperature. Because of the ever-increasing volume and speed of motor traffic, wider and straighter roads are needed. Modern, giant grading equipment makes many such projects economically feasible. Forms are set to the required grade. The fine grading is done by a subgrade finisher. A bridge allows trucks to pass over the subgrading machine. Low spots, after being filled, are rolled. The truck, which is equipped to haul 3 separate batches, is back to the mixer. Individual control of the gates in the truck body allow the batches to be dumped one at a time. 2 batches have already been dumped, and now the last one is dropped into the skip. The rising skip dumps the cement and aggregates into the drum. The extra shake of the skip loosens any sand or cement that sticks. Next, the water is added from a tank where the specified amount is automatically measured. After the proper number of revolutions, the concrete is discharged into the bucket, which travels out the swinging boom and deposits it where desired. The open door of the bucket is often used as a strike-off to distribute the mass. The mixer gang is organized for teamwork, and every man has his allotted task to perform. The shovelers are kept busy distributing the concrete in front of the finisher. For proper manipulation, there is a surplus of the wet concrete in front of the strike-off at all times. The forms are partially filled and struck off at the proper level and the reinforcing mats carefully placed. Then the operator dumps another bucketful on top, and the shovelers quickly spread it for the finishing machine to complete. In constructing the base for a modern vitrified pavement, it is quite generally specified that the base course shall be finished with a smoothness comparable to that desired in the finished pavement. This allows the use of a thin bedding course of uniform depth. Here the finishing machine operator is making an impressed or weakened plane contraction joint. A flat metal strip serves to cut halfway through the fresh concrete. A mark left by the finisher enables them to start it normal to the center line. Turning it flatwise, they slap the surface to smooth any rough spots. This canvas belt on the rear end of the finishing machine makes the final pass that completes the operation. When the finishing machine has passed, an auxiliary curb form is clamped to the regular form. The inside of this curb form rests on the green concrete. This is then filled with concrete, which is thoroughly spaded to prevent honeycomb, and finished with a float. Here, they're striking off a plain sand cushion with a trussed template. Slag, cement sand, and sand mastic are also sometimes used as bed material. The roll conveyor moves along, bringing brick from the roadside to the brick dropper, who seldom fails to put the brick right where he wants it with one sweeping motion. With a long-handled straight edge held parallel to the center line of the road, the inspector checks to see if the rolling has produced a smooth and easy-riding road. Because of the fine records of many old grout-filled brick pavements still in excellent condition, some engineers prefer cement grout filler to the usual asphalt. 1 part of cement to 3 of sand are the usual proportions, adding just enough water to obtain penetration without separation. The surface is sprinkled before grouting. After the joints are filled flush, the excess grout is cleaned from the surface. A dash of kerosene keeps it from sticking to the shoveling pan. Where sand mastic is preferred for cushion material, the usual bitumen content varies from 3 to 5% by weight. As dumping in final position causes unequal compaction, all material is handled again with shovels. The bituminous material makes it plastic, and upon compaction it gains a considerable degree of structural stability. Completely dry or water-saturated sand may run into cracks in the base or shift under loads. The man who drops the brick sets the pace for the whole surfacing operation. So the contractor usually employs an experienced dropper and provides him with plenty of help. I doubt if this fellow can keep up the pace he's now setting. Batting for closure follows immediately the laying of the full-sized brick. Each course must be completed by batting in at the end, if required, using bats not less than 3 inches long. A portion of the adjoining brick is broken off, if necessary, to give the minimum 3-inch bat at the end of the course. In no case are brick broken longitudinally to make a closure. Rolling must commence as near the curb as possible at a slow pace and continue longitudinally, progressing to the center and then passing to the other curb and working back to the center. The rolling continues until the pavement has a smooth surface. Here, the inspector with chalk on a stick looks the pavement over carefully. Brick that have been chipped are marked with a straight line, and if upon removal it is found that the other side is okay, they are turned and replaced with the good side up. Brick with a perfect top surface must have at least 85% of the undersurface also intact to furnish proper bearing. Brick unacceptable because of color or any other reason are marked with an X and are cast out. And replaced with perfect brick. After final rolling, the pavement is tested with a bumpometer, which is merely a 10-foot straight edge on wheels. Deviations from a true plane exceeding 1/8 inch ring a bell indicating a faulty area. If necessary, more cushion is added and the surface rolled again. To facilitate the removal of excess bituminous filler from the surface, an air pressure outfit throws a fog-like spray onto the brick in such a manner that little goes into the joint. This film of moisture is just thick enough to prevent adhesion of the filler to the top surface. There is some possibility that the moisture will get into the joints, so some engineers require that the separating liquid be applied with a brush. This method is more laborious, but also more foolproof. The filler should be poured into the joints with as little heat loss as possible. Do not scatter the filler by careless swinging of the bucket. Hold the nose of the bucket close to the surface, filling the joints full with one pass. When the filler has partially cooled, the surplus mat or carpet of filler is cut from the brick in strips not more than 4 bricks wide. The entire operation should be such as to have no tendency to pull or loosen the asphalt in the joints. The final result should be a clean, nod-skid surface with the filler entirely removed from the brick. The filler thus removed from the surface may be reheated and reused with the correct proportion of new filler to minimize foaming. This sturdy and attractive pavement should serve the ever-increasing traffic of this industrial section for many years to come. Such high-type construction is economically well justified on highways having dense and concentrated traffic. Though higher in first cost than some types, brick pavements are noted for long life and low maintenance cost.